The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's webinar. The topic for today's webinar is going to be the new surface property generator in TracePro. My name is Dave Jacobson. I'm the Senior Application Engineer here at Lambda Research, and today I will be both presenter and moderator. The format of today's webinar is going to be a 25 to 30-minute presentation, followed by a question and answer session. Please feel free to submit your questions at any point during the webinar using the question box in the GoToWebinar control panel, and we'll address all questions at the end of the webinar. I'll try to remind you a few times as we're going along about questions as well. Before we get started, a couple additional resources for anybody that wants to learn more about TracePro. One is we have our past webinars available on our website. So all webinars we've presented will be available on the website. Also, we are recording this webinar, and we will have an archived version or a link to the recording and the slides available on our website in the next day or so. On our website, you can also find tutorials and tutorial videos, as well as information on our upcoming TracePro training classes. Speaking of the TracePro training classes, our next class is here in Littleton at our headquarters. We're going to do 2 days on an introduction to TracePro, and that'll be April 10th and 11th, Tuesday and Wednesday, and also 2 days on optimization with TracePro on Thursday and Friday, April 12th and 13th. If anybody is interested in these training classes, we still do have some seats available, so please feel free to contact us, and we'd be glad to help you out. Also, if you're interested in custom on-site training, we're always happy to talk to you about that. We can come to your facility and conduct training classes there. Great option if you have more than 1 or 2 people that are interested in learning about TracePro. Also wanted to make mention the latest releases of TracePro. TracePro 2018, 18.1 was released on February 12th of 2018. We do have an early visibility release available of TracePro. It's TracePro 18.1.3. That's also available on our website, as well as the current release of RayViz 2018, 18.1. And customers with current maintenance and support agreements are always encouraged to download these latest releases, and you can do that from our website. So with that out of the way, let's actually start with today's webinar. As I mentioned earlier, it's going to be on the new surface property generator tool that's featured in TracePro now. The agenda for today: we'll look at some of the features of the new surface property generator in TracePro. We will also talk about using the new surface property generator to make surface properties. We'll show you how you can use the new generator to read BSDF data, so measured scatter data, and then make a surface property for TracePro based on the scattering measurements. We'll also show an example of making some new surface properties in TracePro. And then lastly, show you a possible method that could be useful if you're dealing with scattering surfaces that have large scattering features, such as Alenod Miro 9. I'll show you a possible method you could use to model those surfaces. And then we'll wrap it up with the question and answers. And as I mentioned, feel free to enter questions at any point during the webinar, and we'll address all the questions at the end. So let's get started. First up, I'd like to talk a little bit about the features of the new surface property generator. It's available in all versions of TracePro. And to find it, you would go to the Define menu, then to Generate Property Data, and then Surface Property. Here's the screen you're going to see when you first open it up. Walk through some of the features of that now. Just as a quick survey of the different menu items that are available. The file menu, you can open a new instance of the surface property generator. You can load a previously saved one. You can save a generator file, or you can exit. Importing lets you import a file. So this would be measured scatter data or existing data from some other format. From there, we can then export either with the model BSDF or with the imported data. View lets us set how we are seeing the results. Is it wavelength? Is it angular theta, so polar angles, or angular phi, azimuth angles? And then there's a help section as well. And in the help section, you'll actually find a lot of good examples on different ways to use the surface property generator, as well as a searchable help feature. So any questions, use the help section in addition to this webinar to learn more about the capabilities of this tool. The window for the surface property editor is broken down into sort of four main segments. First one is we're entering the parameters, or starting to enter some of the parameters for the property. So what's the temperature, the wavelength, the incident theta angle, which is the polar angle, or the incident phi angle, which is the azimuth angle of the incident beam. Then we can look at the properties that we're applying for, based on those parameters: absorption, specular reflection, specular transmission, reflected scatter, and transmitted scatter. So basically all of the parameters you typically see in a surface property in TracePro. Should also mention as well, if anybody needs to know even more information on surface properties, we did have a previous webinar, I think about a year ago, on making custom properties in TracePro. So that's available on our website if somebody wants to dig even deeper into what makes up each of the properties. You can also define in this optical property window the zero axis, which is used when you're doing an asymmetric scatter property. One quick note: asymmetric scatter properties will require TracePro Standard or Expert. TracePro LC only has isotropic or uniform scatter. And you can also determine, is this BRDF, reflected scatter, or BTDF, transmitted scatter. The top main portion of the window is the BSDF plot of any imported data. So if you have scattered measurements, the measured values will show up here in this plot window. And then down below, you can see the fitted BSDF data as a rectangular plot and as a polar plot as well. And lastly, for some of the overall view of the generator, on the right side is where we define any scatter models that we're going to be using. So we can simply right-click here, and then we can choose ABG, elliptical ABG, one-dimensional ABG, elliptical Gaussian, 1D table, or table. So we have several different scatter models available. And I'll show you a little bit more shortly that we can add more than one scatter model. We can do composite scatter models here, but I'll show you that a little bit later in the presentation today. So let's look at how we would make a surface property using this new surface property generator. To start off with, we're going to do a simple property. There'll be no scattering involved. All we're going to have is absorption, specular reflection, specular transmission. So we start off, we open up the window, we go to define, generate property data, surface property. We get a blank property editor panel here for the surface property generator. And we can start off here in the upper left. We can define our temperature in Kelvin, our wavelength, our incident theta or polar angle, and our incident phi or azimuth angle. We enter our initial values here. If you have more than one wavelength, say, you'd have a drop-down table. You can add in multiple wavelengths. So that's the first step. We enter this data. Then we can come down here into the optical property and we can define. Now, because there's no scatter model, we haven't added anything over here, we really only have access to the top three here: absorption, R, which is specular reflection, and T, which is specular transmission. So we're not using reflected scatter, RS, or transmitted scatter, TS in this case. And we come in, we can manually enter values here. We could type in this case, it's 10% absorbing, 60% reflected, and 30% transmission. We can also use the sliders. We can just move the sliders left and right to set the values like that. And anybody that's made properties before in TracePro for surface properties may remember there's a solve for feature, meaning we could enter in a value for reflection and a value for transmission, and then solve for absorption. And that's implemented here as well. We just check the box next to the parameter that we want to do the solve for. So in this case, I'm entering reflection, entering transmission, and then solving for absorption. And this ensures that we have conservation of energy, because we want these three values to add up to 1. And as we can see, they do in this case. We then repeat the process if we want to have any additional temperature, wavelength, incident thetas, or incident phi angles. We can add in this case a 0.75 micron wavelength. And we've changed our reflection and transmission, our specular reflection, specular transmission values here by a small amount. And we'd repeat that process for any additional parameters we'd want to have. So we build up the property sort of layer by layer. Next, when we're ready to export the property, we want to export it and save it in our TracePro property database. All we need to do is go to the export menu and then export with model BSDF. In this case, we don't have BSDF data, but we're still selecting that export with model BSDF. When you click that, what happens now is it's going to open up the export property with model BSDF window. We can see here, here's our parameters. We have a 0.5461 micron wavelength and a 0.75 micron. Our absorption, reflectance, and transmittance values for those two different wavelengths. We can give the catalog name. Where do we want to save this property? So in this case, I have it creating a new catalog named webinar and a property name. In this case, webinar, 1. And then we can simply click the export button here. There's also a solve for option here if we wanted to double check. But we can click export and then say export to TracePro. And then here's the property now in TracePro. Our two wavelengths, our absorption, specular reflection, specular transmissions for those wavelengths. So now this property is in the TracePro database, the property database, and available for any models you want to use. So going forward, you have access to this property. Okay, what if we want to add scattering to this? That was a very simple example. No scattering, just specular reflection, specular transmission, and absorption. Let's say we want to look at scattering. So we start off the same way. We go to define, generate property data, and then surface property. And we open up the surface property generator. These first few steps are exactly the same. We can enter in our temperature, wavelength, incident theta, incident phi angles. So this is polar and azimuth, same as we did the previous method. But here's where we get to a slightly different step. Now we're going to want to right click in this pane here on the or portion of the window on the right side. Right click, choose add BSDF, and then select the model you want to use. Again, we have ABG, elliptical ABG, 1D ABG, elliptical Gaussian, 1D table, and table. So in this case, I'm going to use an ABG model. Now, because I'm adding in ABG in a scatter model, and here's what this looks like to start off with now, because I've added in a scatter model, it now gives me access here to the RS reflected scatter and TS transmitted scatter terms. So once again, we can also use the solve for option by clicking. For this example, I'm going to use a solve for reflected scatter. And I'm going to put in my absorption as 0.1, my specular reflection is 0.05, and the solve for and reflected scatter gives me 0.85. Okay. We can see here's our scatter curve at this point. To change the scatter, to change the BSDF curve, we have a couple options. One is we can pull on these little blue control points or control boxes here and manually adjust the curve. And a lot of times you're looking down here, here's the BSDF versus theta, or the polar angle. So we can make this shape here wider, narrower, taller, shorter by adjusting the values here for these two control boxes. Also, you can enter the values directly into the ABG dialog box here. So I have a zoom in on that one. So this has a value of G is about 2, B is 0.02 or so, and A is relatively small, 0.00072, I think. But we can easily adjust these values to play with this curve and get the shape of the scatter that we want. And then after we do that, the process is the same. We're back to the same as we did with a non-scatter model. We go to export, export with model BSDF. In this case, I'm keeping the same catalog. I'm going to put it in that same catalog named webinar. I changed the property name, webinar, 2, webinar property, 2. Just to be sure, I could do a solve for, in this case, solve for BRDF. And then I can export the property to TracePro. You do also have options here. You could save this to a file, in which case it would create a text file of the property, but it would not add it to the TracePro database. That can be useful if you want to send the property to somebody else. We can just export it without creating the text file, or we can save and export, create the text file, and add it to the TracePro database. And here's our new property in TracePro now, webinar property 2. Absorption is 0.1, specular reflection is 0.05, and our integrated BRDF is 0.85. And then here's the ABG parameters from that model. So those two examples were making new properties with values that we've come up with ourselves. Now let's look at using the new property generator to take measured scatter data. So if you send a sample out to one of the companies that can measure scattering, they'll send you back a file that we can then load into this utility or into this generator. So again, we start off with a new instance of the property generator. So it's define, generate property data, surface property. And now what we're going to do is we're going to go to the import menu and choose file. In this case, we don't need to select the file type. The generator will look at the data and determine which type of scatter measurement it is. Is it a CASI measurement? Is it a ScatterWorks? Is it a ScatterScope? Is it Opsira? Is it Lightstar? Is it Alanaut? So it'll read and determine the scatter type, and then import the data. Over here on this in the window here, we can actually see the imported data, the scatter measurement. There's a box here where we can turn on whether we're showing the data or not. We can filter out the specular if there is a if there is a sharp specular peak. You could possibly filter that out and set the exclusion angle to say filter out 1 degree or less than that or something like that. So here's our imported scatter data. I can then right click here in the model in this pane, right click, choose in this case ABG. That'll add in a generic ABG curve here. And then as I mentioned in the previous one, we can use these control boxes, the blue control boxes, to move this red curve and fit it to the scatter data. So we can move this up or down, slide the roll-off points, the slope of the roll-off, basically anything like that. We can adjust this curve to fit the data here. And down the bottom here, we'll have the actual curve, which is the gray line, and the blue fitted curve is in here as well. And in this case, there's a good overlaying of the two. We can come over here, and in the optical properties, the reflected RS, reflected scatter, is actually coming from the integrated value up here of the scatter measurement. So in this case, it's 0.0165. We could enter an absorption, let's say a generic value of about 5% absorption. And then we could have it solve for the specular reflection. We'd repeat this process. In this case, this measurement had a 10-degree incident angle, 45-degree incident angle, and 75-degree incident angle. So we'd repeat the process for all 3 incident angles, and then export the property just as we did before, going to export, export with model BSDF. We give it a new name. And here we see we have our 3 incident angles, 10, 45, 75. And then the absorption, specular reflection, and BRDF of those for those 3 different angles. Export that to TracePro, and here's the resulting property in TracePro, now available for use. 3 angles, 3 incident angles, 3 absorptions, different specular and integrated BRDF for those. So fairly straightforward, very easy to come in. Fitting the curves sometimes takes a little bit of practice. Ideally, you'd also have a total reflectance measurement so that you can use that to set what the absorption value is. In this case, I made an estimate of about 5%. Now, an additional feature here, and this is something new. This is something we haven't really had before. But some scatter models do not cannot be fitted very well with a single ABG model or standard ABG model. Let's say this is a scatter profile that we're looking for. We can see we have a fairly sharp peak here in the center from about +10 to -10 degrees, and then a bit of a shallow roll-off heading out towards 90 degrees. What the surface property generator allows you to do is add 2 ABG curves to the model. So here I right-clicked, choose ABG for my scatter model. Then I did a right-click again, add scatter model, or add BSDF model, and selected a second ABG curve. And now what we have is this dark blue curve here is one scatter model, and this light blue is the second one. So we're using the first scatter model here, the first ABG curve, to model this and then down to this roll-off here. And then the second scatter model is modeling this shallower roll-off here. So we can actually fit more complex curve shapes by using these by using these multiple ABG. And you can have more than 2. 3, 4, 5, depending on how many you really need to get the job done. Here's the property as it was set up in the optimizer, as it was set up in the generator. And then here it is exported to TracePro. It actually uses 2 scatter profiles here. And here's the curve. And it's a pretty good fit to the initial curve here. It's a little bit different starting about here, maybe out at about 50 degrees. So maybe we need to add in even a third curve to cover this wider area here. But it's not a bad fit. Okay, so last topic before we wrap up the webinar. And as I mentioned, please feel free, if anybody has any questions, please feel free to type those in that question box, and we'll look at those at the end. So a problem we run into sometimes, and this has been asked of me by a few customers. This is actually a presentation, or part of it's from a presentation that we did at the LED Professional Show in Bregenz, Austria, back in, I think it was September of last year. But when you're using materials or surfaces with large scattering surfaces, such as Alinod Miro 9, ACA 47900 OC, or Anifol medium hammer tone, the traditional method of measuring BSDF and then using the data to make a scatter property might not work properly. The main potential problem is that the laser or the light source used to illuminate the sample is typically going to be smaller than the size of the texture features. So the surface finish may actually be highly specular, but adding the texture, the large textures, works to scatter and diffuse the light. So if your illumination source in the scatterometer does not adequately sample a large enough area, the resulting BSDF model may be more specular than the overall actual surface is. So here's an example of Alinod Miro 9. People that have done illumination design have probably seen materials like this at times. So the challenge is, how do we make a BSDF property from this? And as I mentioned, one of the problems is that many scatterometers use a laser as an illuminating source. And we can see here's 3 different positions for the laser where it's hitting this. This is a model of that Miro 9. But depending on where the illuminating beam hits this surface, we get different scatter patterns. If we hit right in the center, it behaves quite specularly. If we hit on an edge, we get scatter in multiple directions. So a possible solution is to make a CAD model of a representative area of the surface, apply a surface property to the model to model the equivalent scattering of a flat surface, and then run a ray trace with the model in an optical design and analysis program such as TracePro. And then the results of this ray trace can be used to make an equivalent scatter property of the surface. In effect, what we're doing is creating a scatterometer with a very large beam. And I'll show you in a few slides here what that is. And then the scatter property, the resulting scatter property, can be applied to, like any other surface properties in the model, and used to model the effects of these large textured surfaces. So really what I'm hoping to do here is to show another use of this new surface property generator. So here's a case. I took a picture of the Miro 9, and I opened it up. I added the bitmap of this into the 3D optimizer in TracePro. And the reason I did that is it allowed me to draw these objects here that are representing the features or the dimples on this piece of Miro 9. Now I did a large enough area. I didn't do the entire sample size here, but I did a large enough area to kind of get a representative picture of the pattern. after I made the initial object in TracePro, and I did that by modeling a piece of, a rectangular piece of, or a rectangular object, and subtracting each of these shapes from that from a depth. I measured the depth of the features, and I subtracted these, doing a Boolean operation here in the optimizer. The problem with that is it left me with features that had straight walls or straight sides. So what I did is I took that model, I opened it up in SolidWorks. I imported it as an SAT file, I believe. And then in SolidWorks, I added radiuses to the edges, both the top and bottom edges of all these features, or dimples as I like to call them. So now we have a better representation of what the actual surface looked like. So from there, I then exported the model from SolidWorks and opened it here in TracePro. So here's a sample of this Alanod Miro 9. If we go back here, this is what we started with. Actually, this is what we started with. Here's a TracePro model of it now. Now the next step is I need to apply a surface property to this. And what I did is I had one of my colleagues actually had access to a scatterometer, and they measured the scattering from one of the center, or one of these flat areas at the center of one of these features. So we made that. We made a scatter measurement, and I believe we used the ScatterScope 4 from the ScatterWorks. We made a scatter measurement on the flat area of that Miro 9 sample, and we imported that in here into the surface property generator, and we made a surface property based on this. So this is a surface property as if this whole surface was flat. But now we apply it to our 3D CAD model where we have the dimples and we've physically modeled the texture. And then we illuminate a large area in TracePro. So here's the advantage. We can set our beam to really any size we want. I'm not limited to a fraction of a millimeter from a laser source. I can illuminate a very large area of this sample, and then I can look at the candela plot. So here's the candela values here, the candela plot. And we did this at, I think it was 10, 20, 30, so 0, 10, 20, 30, 40, 50, 60, 70, 80, and 85 degree incident angles. So we're able to illuminate this at a lot of different incident angles, saving the candela plot at each time. The candela plot can be opened up in the surface property generator. The surface property generator recognizes the TracePro candela plots as a possible scattering file. So we did that here. We opened this up and we fit the data for all of these angles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different incident angles from 0 to 85 degrees. We fit the data for each instance, made the property here in TracePro. And really the ultimate goal of this was to make a property that would model the effect of those features, those large dimples, without actually having to make the CAD model each time. Because if we wanted to make a large area of this, make this into a reflector that might be shaped into a parabolic curve or a circular curve, to make a CAD model of that would really take a long time. It wouldn't be a very effective use of time. So ideally, we want to be able to apply the scattering property to a smooth surface, but have the effect of that large texture. So here's this surface with that Miro 9 texture applied to it. And here's the resulting scatter. So here's the CAD model results. And then here's the results with the ABG scatter property applied to a flat surface. And out to about this point here, they're in very good agreement. There's a little bit of a change here as this drops off, but this is a log scale here on the left. So we're probably 5 or 6 orders of magnitude down before we see this change. So it's a relatively small loss right there, a small difference. Now, a big advantage of this, and this was sort of an unexpected advantage when I ran this and did this presentation, is that tracing 1,000,000 rays with the CAD model took just over 5.5 minutes. Tracing that same 1,000,000 rays with the ABG scatter model took 13 seconds. So significantly faster by doing the CAD model here, probably about 25, 26 times faster by doing a CAD model, by doing the ABG model compared to the CAD model. So a significant savings in ray trace time. Plus, we can now apply this property to any shaped reflector that we make. We don't need to worry about adding that dimple feature in and really taking a lot of time in CAD. And just to show a little clearer, plotting the results here in this case in Excel, we can see pretty good agreement until we get out to, maybe 40 or 50 degrees past the specular point. This is the 40-degree incident beam here that we're showing. So to wrap it up, and again, I'll put out a call for questions. If anybody has questions, please feel free to submit them, and we'll talk about them in a few minutes. But just as a little bit of a summary, TracePro now features a new surface property generator tool. And this allows you to easily make and export new surface properties, both with and without scattering, and export them to TracePro using this tool. We can also import measured scatter data into the surface property generator and make new TracePro surface properties from that. And we can also use it in conjunction with something like a CAD model of an object that may not be something you could measure easily with a scatterometer, such as a material with large scattering features. And then we can sort of lead to easier, by making the property using the generator, make ABG properties that we could use in TracePro to get to easily model large features like that, and it leads to faster ray traces. If anybody wants any additional information like this, or wants to sign up for one of our free 30-day trials, please visit our website, www.lambdares, or call us here in the US, 978-486-0766, or email sales@lambdares. With that ends my presentation. As I mentioned, we are recording this, so the recording will be available on our website probably within the next day or so, maybe I would think Monday at the latest. And I will open it up for questions now. I don't see any questions at this point. So obviously, if anybody does have any questions, please feel free, add them in here. Or if you have questions afterwards, please send them off to our sales@lambdares email address, and we can always address them later. Okay. As I said, I don't see any questions at this point. So why don't I close the webinar out here? But please feel free. Any questions, send them into our sales email address, and we will get back to you as soon as possible. So I'd like to thank everybody for their time today, and we look forward to seeing you on our next webinar. Have a good day. Bye.